Here we have been asked to compare the reactivity towards hydrolysis using aqueous acid of the following organic compounds. Now, the concept says that hydrolysis is going to be a very important keyword here in our question. Hydrolysis, it basically implies the reaction with H2O, and one thing that we know very well is that H2O or water, it is basically behaving as a nucleophile due to the presence of lone pairs. Thus, H2O is a nucleophile. So then we have to find out that which of these three compounds is having the highest electrophilicity, that will have the highest reactivity towards hydrolysis. Now, looking at these compounds, what we know in all these compounds is that the carbonyl carbon, that location is going to have the highest electrophilicity or highest positive charge in the compound. So here I have the carbonyl carbon, here I have the carbonyl carbon, and here also I have the carbonyl carbon. And one more thing that I am able to observe here is that a portion of all these compounds is going to be common. Like here you can see on the left side of the curve, we see a ketonic functional group and a methyl group. Here also on the left side of the line, we are seeing the same thing. Here also on the left side of this curved line that I make, you are able to see the same thing. Now let us focus to the groups that are present on the right side of these curves. Here we see a methyl group. We know that methyl group is going to exercise an I plus effect or positive inductive effect. Then when we look here in the second organic compound at a nitrogen atom, we know that it has lone pairs. So here we know that it is going to exercise a R positive type of resonance. Here we know that a chlorine atom, it basically behaves as a I minus group. So what we understand is that if electrons are going to be donated to the carbonyl carbon, the positivity is going to decrease. But in I negative, what we observe is that the electrons from the carbonyl carbon region are going to move towards a chlorine atom, and thus the carbonyl carbon atom in the third organic compound is going to be the most positive, the most electrophilic in nature. It is going to attract water by a very large force, and thus reactivity will be very high. Thus, third organic compound has the highest reactivity towards hydrolysis. And now what we observe is that we have a standard rule that A, E, R, H, I. So what we observe is that there is no aromaticity in the above cases. There is no equivalent resonance in the above cases. Resonance is observed in the second organic compound. There is no hyperconjugation, but we are having a I plus effect. R plus is going to donate higher amounts of negative charge. I plus is going to donate lower amounts of negative charge. Thus, somewhere and somewhere we can say that carbonyl carbon in the first organic compound is going to be more positive compared to the carbonyl carbon in the second compound, as more electrons will be donated here due to the R plus effect. Thus, after a thorough analysis of all the three options, what we can comment is that option D is the appropriate answer.